Hello, algebra students. Today we are going to be doing something called factoring, or what I like to call the big F word. We learned the big F word the other day, FOIL. Today's the big F word, factoring. And we're going to be factoring for quite a while. Many different types of factoring that we're going to learn. Um, it's actually really pretty easy if you just learn the different patterns. Factoring is like the opposite of distributing. And that's how I want you to think about this. The first type of factoring we're going to learn is called factoring by the GCF. It's the first type of factoring we learn. It's always the first type of factoring you're always going to try. Always going to try. I only said always several times there for a reason. So let's take a look at this example here. 8x plus 4. We want to factor out the greatest common factor. In other words, we want to undistribute. Can you think what was distributed? I mean, this problem, our answer is going to look like some number times, something like that. It's not going to be that, but it's going to look something like that, okay? So think of 8 and 4. What is the greatest common factor of them? Well, if you're not sure, you can list the factors of 4, 1 and 4, and 2 and 2. And notice I'm very deliberate how I do that, and I'll show you why in a minute. And I'm going to start with the biggest factor, 4, the greatest factor. Is 4 a factor of 8? If it is, it's part of my GCF. So I'm going to identify my GCF. It's going to be 4 in this case. So I am going to undistribute a 4. In other words, I'm going to divide out a 4. 8x divided by 4 is 2x. 4 divided by 4 is 1. And there you go. Doesn't this look like a problem that says, hey, I need to be distributed? Now, we're not going to distribute it because that would take us back to this, right? We're just going to go ahead and distribute out the 4, and then we're going to be done. So in a sense, we're going backwards. We're using the inverse operation. We learned how to distribute, learned how to FOIL. Now we're learning how to go the opposite direction. Okay, so over here, if you don't know the GCF of 16 and 24, you really should. But I'm going to list the factors of 24 and watch. I'm going to be very deliberate. I'm going to start with 1 and 24. 2 goes into 24. How many times? 12. 3 goes into 24. 8 times. 4 times 6. Now, I'm not going to, all I have to check now is 5. Because notice how the left-hand column climbs and the right-hand column declines, gets lower. Well, notice 4 and 6, the only whole number left to check between them is 5. I know 5 doesn't go into 24. So now, oh, I'm sorry, I should have started with 16. That's a good exercise that I did that, but it's unnecessary. But let me go ahead and do it this way. I'll do the factors of 16. Okay, 2 and 8. 3 doesn't go into 16. 4 and 4. Okay, now I'm going to look for the greatest common factor in the black set and the green set. Well, looks like 8 shows up in both sets of factors. So 8 must be the GCF. So I'll factor out an 8. That means I'm dividing, so that'll be 2x. And I'm dividing there plus 3. And there you go. You're done. It's pretty simple stuff, especially if you know your factors, all right? Now again, it's easier to just list the factors of the smaller number. So 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. And notice I don't have to check anything else. All right, so it looks like 4 is the greatest common factor because I know 36, 18, 12, 9, and 6 do not go into 40. So, but look at this, I got an x squared and an x. What's common to both of them? Well, doesn't x squared really mean x times x? And aren't they factors? There's 1x, isn't there? That's common. My GCF in this problem is going to be 4x. So I'm going to factor out a 4x. If I divide 40x squared by 4x, I'm going to get 10x. And if I divide 36x by 4x, I'm going to get a positive 9. And there you go. All right, it works on trinomials too. In fact, we're going to be doing a lot of trinomials. I'll bet you can tell me part of the GCF without listing all the factors. The GCF, the coefficient's going to be 5. Now, how many x's are common? Well, there's 1, 2, 3, 4, 5 here, 1, 2, 3 here, and 1, 2 x's there, right, from the x squared. So it looks like they all have 2 in common. Or in other words, an x squared is in common. So my GCF is going to be 5x squared. So I'm going to divide each of these coefficients. Whoa, I lost part of my number there. Going to divide each of these coefficients, each part of this trinomial by my GCF. And so I'll divide by 5x squared. I'll divide by 5x squared and divide by 5x squared. And my answer is going to be the GCF, 5x squared, times the quantity of 12x cubed plus 7x plus 3. And there you go. There it is. All right, number 5. Going to do the GCF. All right. You may not know the GCF, so I'll take the smallest coefficient, 21, list its factors, and I'll be looking for the largest or the greatest of these numbers that goes into the other ones. Well, I know 21 doesn't go into 28, so it's not common to all three. It does go into 42, but it's got to be common to all the terms. 7 goes into 28, and 7 goes into 42, so the coefficient of my GCF must be 7. Of the x's, it looks like x cubed is going to be common to all of them. So my answer will be 7x cubed, and I'll divide each term by 7x cubed. So I'm going to get a 6x to the 5th, a minus 4x squared, and a plus 3. And there you go. That is factored using the GCF method. It's pretty easy stuff, especially if you know your factors, multiplication tables. If you don't, you can go ahead and review them because it'll certainly help you with what we're going to be doing. All right, that's it for today's lesson. Mr. Lawrence signing off. Good night, everybody.